I'm going to do only two calls today, which is push and what is the next? Pop. Okay. One is push, the other is pop. And we are going to work with lists. I hope some more familiarity is coming with lists. So I'm going to talk about a stack. See, we need now two things to be covered. Now I'm going to talk about what is a stack and what is a queue. I think I did. Acha, brief. Okay. Then I think I'll start with that overview. What is a stack? I think any kind of data structure which supports what is called LIFO, last in, first out, is called a stack. First in, first out is called a queue. Now what does that mean? Okay. So let's take a specific example and understand how a stack works. Okay. So this is normally the impression that is there in stack. Now this is a conceptual stack. Generally it is modeled in memory, either increasing memory or decreasing memory. Now I am showing it as increasing memory, but people model it as decreasing memory also. Decreasing memory means from higher memory to lower memory it will grow. I am showing lower memory to higher memory. Both are fine. So what happens? So when I say push 5, this is conceptual. We are going to implement it using a linked list, remember? I'll come to that in a moment. Push 5. Okay, conceptually. Then push 10. So 10 gets pushed. Again, I am saying conceptually. Then I say push 7. So 7 gets pushed. Then I say printf %d \n. I say pop. When I say pop, what needs to happen is this 7 has to be popped. Okay. So now what will get printed on the screen? 7. Last in, first out. What went in last? What was pushed last came out first. So now conceptually the stack will be only 5, 10. Again I say same printf, exactly the same printf. Now what should appear on the screen? 10. And conceptually my stack has now only 5. Okay. Again I say same printf, I'll get 5. Okay. Now I say printf again, the same printf, I say it again. What will I get? I'll get an error saying stack underflow. This is called underflow. Overflow means you cross the limit of the size of the stack. Okay, that is called an overflow. And underflow is basically coming down. Okay. So we have this conceptual operations called push and pop. Now we are going to implement. Is everybody clear what is push pop? Push pop. There is nothing conceptual about it. What goes in last comes out first. LIFO. L-I-F-O. Okay. Now, coming to the implementation using linked list. Actually, the way we are creating a linked list, we are ideally suited for implementing the stack. So it should be pretty easy. So let's say my linked list is right now 5, 10, 15. Now its conceptual version of this would be 15, 10 and 5. This is the conceptual. This is the actual. Now, when I say push now, let's say I push 25. How should my linked list be? It should be 25, 5, 10, 15, correct? And my conceptual picture will be 25 here. So this is how my linked list should look, and this is the conceptual picture. This is not important, this is just to understand what that LIFO thing means. Then again I say push 17, how should my linked list look? 17, 25, 15, 5, 10, 15. And 15's next is null. So now, when I say push 17, this is how it is. So my stack should look like this. Okay. Now you understand what I am doing, right? If I am pushing a particular data element into the so-called stack, which is internally a linked list, what do I need to do? I need to create a new node. I actually need to do just add node and take the new head and keep it with me. Correct? My add node is doing exactly that. Isn't it doing that? It is just adding one more node with that data at the head. So our add node already is oriented towards working towards stack. When we implement queue in another session, you will realize queue is going to become a problem because I have to add at the end, not in the beginning. Here I am adding in the beginning, so my add node is taking care of the situation. Because the way we wrote add node was add to the head. Okay. Now, if this is my linked list, 17, 25, 5, 10, 15, let's go to the next page. So my linked list is 17, 25, 15, no? 5, 10 and 15. Okay, whatever that linked list. Now, if I say pop, if I just say pop, I should get an integer back. What should be the integer? How should the linked list be? The response to pop should be 17. That is, the value returned by pop should be 17. You agree with that? Because I am popping from the list in a LIFO order. What went in last came out first. I say pop. When I say pop, I should get 17. And how my linked list should look? 25. Because 17 has to go away. 5, 10, 15. This is how my linked list is going to look after the first pop. And answer I am going to get is 17. And this is how my linked list looks. If I say pop again, okay, then I should get 25 as my answer. And my linked list should be 5, 10, and 15. Now, my push was very easy. I just had to add at the top. What do you think I have to do when I say pop? I have the head with me. Remember, I always have a head. So whatever data is there in the head, I have to give back and I have to advance the head. That's all. 1 line, 2 lines. Yes, no. What do I have to do? My head, just think now. Right now, in this linked list, where is the head? This is the head. Agreed? So when I say pop, what are you going to do? You're going to first read the data in the head, return it. No, don't return it immediately, but read the data in the head. Then advance your head. Correct? If you advance your head now, your head will be here. And whatever is the data here has to go. And you will have to remember to delete this node or free this node. Yes? Because this node is no longer there. So a few operations and pop will work. Okay. And there is one more situation where pop may be there when head becomes null. So if head becomes null at some point when you have popped, let's say 5 times, my head is going to become null. At that time, the 6th pop, what it should do? It should say the head is null. So report some -1 or something and say, there is a underflow error. Correct? You can also limit this in the push operation that my linked list size, you can maintain a variable size which tells you how many nodes are there currently in the linked list. So you decide that I am not going to have a linked list more than 10 nodes, right? So if somebody tries to do push 9 times, it will work. 10 times also it will work. 11 times somebody tries to do a push, he should say overflow. Stack is overflow, okay? Because I have decided that at any given time, unless you do a pop, I am not going to allow any more elements to come in. You do a pop, then one element goes out, I reduce the size by 1, then you can push another element. Agreed? But you can't just go on pushing 10 pushes without a single pop, right? You have pops in between, we'll allow that many elements more to be accommodated. But if you don't, then we are not going to do it, okay? So we are going to implement this. What I'm going to do is, I'm going to show you a main, and then I'll show you the functions. First, I'll give you the code which we wrote. We'll give you the last code that we wrote because it's all you can make use of it. Not all of it is needed, only add node is needed actually. Okay, but it's okay. You get the whole code, and we'll give you the whole code, and then I'll change the main to do something, and let's see how it works. I'm going to write a main first, and then I'm going to give you some time, hoping that you will write the push and the pop on your own. Okay, so we are going to say our size of the stack is 5. I don't want 10 because our program will become too big. So couple of changes you have to do to the code, quite a few. Size, please remember, our stack size upper limit is 5. You have to implement that, okay, by putting a size variable. Okay, now I'm going to knock off this code entirely. We are going to knock out the main. Main remains with you. No, don't knock off their main. First give them the code. Given? Okay, our code is in 49. You are seeing it in 49? What we have done so far. Okay? Yes? Everyone has 49. Okay? So, yeah. Now, I am going to write only the main. You are going to write the functions on your own. Is that okay? So, and please remember my stack is only 5. Okay? So, I'll say push 10 semicolon, push 20, push 30, these are not there right now, these functions. This is what you are going to implement. Push 30, push 40, push 50, push 60. Now, when I try to push 60, I should get a printf saying stack is full. Do you agree? No, yes? Because now you can't push. We are saying you have to ensure that the stack stays at not more than 5 elements at any given time. Okay? Then we will say printf %d space \n. Okay, pop. At this point, what should I see? How much should I see? 50, not 60. 60 is rejected. Agreed? 60 doesn't go into the list at all. Doesn't go into the stack. You are agreeing with me? 60 won't go. So when I say pop now, I should see 50. Agreed? Okay. Now I'll say pop again. Now at this point I should get 40. Do you agree? 40. Now I'll push again. Push 25. Okay. And then repeat the printf again there. Okay. What should I get? I should get 25. The last guy who went in is 25 now. Yes? So I should get 25. So this will check whether your stack is working correctly or not. Whether you are able to push correctly or pop correctly. Correct? Is this something you can do? We have given you the code. We have given you the add node, all that. You have to implement 2 functions. Size is 5. Head is anyway there. So you have to implement these 2 functions, push and pop, so that we get consistent behavior like a stack. But you have to use a list, the same code that we have done. So to that you have to add 2 functions, push and pop, and get this code to work. Okay, don't change one line in main. Are you with me? The main will stay as it is. Whatever changes you do in the earlier code, basically write these two functions. I'm hoping that more will do. So struggle a bit. I think a lot of you will finish. Okay, do it. Struggle with it. Understand add node. Understand what you are going to do with push. Push is nothing but add node with a little flavor. Only check whether the size is exceeding. That's all. It's very similar to add node. In fact, it's add node only. Very easy. Push is very easy. Pop is also easy. Push will check for size. Pop will check for head also. Okay, we'll give you 20 minutes. Okay. So I think I'll start solving. You already have the code. So I'll start with writing the push. Okay. Whenever you write a function, you have to be careful what it gives back, if it gives back something, what it takes as a parameter. Okay. If you see our main, can we go to the main? Push just takes one parameter, which is an integer. So from that integer, I have to create a node and do. That is what my add node is also doing. So I'm going to make use of add node and do that. So let's go up and write push. Because it's going to call add node, I will write it before that. I can write it anywhere after line 7. Okay. So let's write push. Okay, wait. What is the return type of push? What should be the return type of push? Void, no? I don't want push to return anything. Void is good enough, no? No, yes. So return type of push is void. That is, I don't want anything back. So void push. What is the parameter it takes? Int, it takes a parameter. Int D, the data that I want to push. Okay. Now, I have to create a variable in global variable called size. Remember, I can't push more than the size. Size will increment with every, so I have to create two variables. One is size, which is the maximum size, and current size. Current size indicates how much is there already in the stack. Okay. So we'll create two variables after line 7 outside the function. Let's create those two variables. The two variables are int size. Okay. Generally, we say that size, I think I should use this occasion to introduce a hash define. So let's remove, go to the top. I'll do a hash define, which is, I'll talk a little bit about it later. Hash define size as 5. Okay. Now, this is a very common use of these macros. This hash define are called macros. So I have created a macro. The name of that macro is, or rather I should say, I have defined a macro. What is the name of that macro? Size. What is the value of the macro? 5. So when do I use this kind of hash defines? You need it for quite a few programs. For example, in an area of a circle. The area of a circle or a perimeter of a circle is dependent on the value of pi. So I'll create a hash define on pi. So I'll say hash define pi something 3.14. So if I have to change it, I have to change it at only one place. And it is convention that such predefined constants which you need in a program, as I said pi, sometimes you'll need, if you're doing a chemical equation, you'll need the Boltzmann constant or Avogadro number. Some equation if you're writing, that equation may have some constant like Planck's constant. So you will need those. So hash define serves as a good way to provide those constants because they are not going to change. Like the Avogadro number was the same since hundreds of years, since it was discovered. Okay, the number of the molecular weights and all those kind of things, I forgot all that. Okay, so all of those are predefined numbers, so they don't change. Or equations also. sometimes you want to write volume of a sphere. So it is 4 by 3 pi r cube. So that 4 by 3 is going to not change, right? So you fix that value. So like that we are saying hash define size as 5. Then we'll define one cur size variable after line 8 tarvata, called int cur size, which gives the current size of the stack. So I'll say cur size equal to 0, because initially the stack will be empty. This cur size and size will help me identify how big my stack can be. Okay. Now I'll say if cur size, so first time after the first element cur size will become 1, then 2. So if cur size is already 5, I cannot insert any more elements, correct? Would you agree or not? Or the way I would write it is, if cur size, which is the current size of the stack, equal size already, then I should not be doing any push operation. I should just say printf. What will you call it, overflow or underflow? This is called a stack overflow, that cur size has cross size.
Sir, why don't we use a variable for size instead of hash define?
You can. No, for size you can use. It's convention. If you want to do int size equal to 5, be my guest. No problem. It's not wrong. But I am saying convention. Convention is these hash defines. Okay. If you ask what is the nitty-gritty difference, okay. Since somebody asked, I am addressing it. Can we go up? Yeah. When we define hash define size as 5, okay. It's a good point to say at this point to explain. Size, if I say int size as he suggested, int size will take memory. How much memory? Big enough to whatever, 4 bytes. If you declare it as int, it is 4 bytes. SIZD size, the way I have defined it as a hash define, it's called hash define because it starts with a hash and then define. So if I have used a size like a hash define, it doesn't take any memory. Why? Because what happens is, while compiling the program, there is something called a pre-compiler. So the pre-compiler, which is part of your compiler, it's invoked automatically. What it does is, it looks at all the hash defines and picks up their values, like 5, and then it just blindly will substitute. So after the pre-compiler, line 12 will look like if cur size equal 5. That is called pre-processing by the pre-compiler. Pre-processing means before the compiler even looks at it, the compiler will never see size, SIZD size. Are you with me? The compiler will only see 5. So no memory has to be allocated. 5 is not a variable. And if size is used in 10 different places in the program, in all 10 places, it will substitute size with 5. Who will substitute? The pre-compiler. Before the compiler kicks in, there is something called pre-compiler. So in a nutshell, to answer this question, size, if I make it as int, it will take memory. If I leave it like this, 0 memory. Because it's just a page replace, wherever size is there, it will be replacing with 5. No memory is allocated. That has advantages and disadvantages. In this case, it's good to define size as a macro hash define. So how can I use it? Just like I use any other variable. Okay. So if cur size equal size, that means I have no more space. Are you with me? I am done. It's gate closed. So I say printf stack overflow and return there itself. Because I can't now proceed with the function. They're meaningless to proceed with the function because I don't have space to accommodate this guy. So I say stack overflow and come out right there. I'm done. There's no return value, no? Okay. Now, so fair enough. Now, the fact that the code reaches after line 16 means what? Cur size is not equal to size, although it's less than size. Do you agree? Otherwise I will come out. right there. Now the fact that I reached line 17 means there is space in the stack for adding data. And what am I going to use to add data? I am going to use add node, which will look at if head is null, it will do all of that story. And if it is not null, it will add to the top. If it is null, it will create it and give me a head, right? A valid head. That is what add node does. So what I'll do is, I'll just say, I'll call add node, look at the invocation of add node is such a nice guy. Now, I'll simply say add node, just data. What data? D. Now, actually if you examine add node carefully, it has a return type. It gives a new head pointer. Just look at it. You will see that it has a new head pointer. Now, I know head is automatically getting updated because head is a shared variable in the program, global variable in the program, it's available. So, anyway if head is getting updated, I'll call add node with D. So, what it will do? It will update the head, yes, or it will create a new head. I mean if head is null, it will create a new head. If you look at add node, that is what happens, okay. So, I have said add node D. So, a new node has been created in the list. I am using add node D. I have added a node D. So, as I said before, head may get updated or head may not get updated. Depends on whether I am adding at the head or adding somewhere at the end. Oh, head will always get updated because I always add at the beginning. Yeah. Okay. There is just one line which I have missed. Can somebody help me with that? Beautiful. I should say cur size. Should it not increase? I have pushed a new node into the list. My size should go up, no? Common sense. So in the else part, I have to say either cur size plus plus or cur size is equal to cur size plus 1. Okay? Yeah? Everybody with me? This is how you do pushing. What did I do? I used add node which pushes a node at the end, at the head. Head will get updated. It will get internally updated, I don't care, because head is a global variable. Then I have only bothered to check whether the size is equal to size to see overflow, and I have incremented cur size. That's all. So that is all I am expecting in push. My push is hopefully going to work. I don't think I have missed too much. Now, let's write pop. Okay? So let's give pop a shot. What is pop's return type? Pop has to give, look at the code now, go to main. Look at main. Okay. You see line 134 where pop is called. We are expecting something from pop now which we want to print there. So pop has to give us something, correct? If it has to give us something, it should have a return type of a whatever return type, int in this case, because it's a stack of or a list of ints. So now we'll try to write pop. So let's write it here. So int pop, and it works on head. Okay, pop. Okay. Okay. Now, just like we said overflow there in case of push, where will I say underflow in pop? When there is nothing in the list, then I should say underflow, no? Underflow means nothing there in the stack, you are trying to pop something from from a stack which has nothing in it. How do I write that part? Yeah, if cur size is the variable I am using to keep track of my size of my stack, current size of my stack. So I will write this piece if cur size equal 0, that means it's an empty stack, there's nothing. So cur size equal 0, what should I do? I should say, you're trying to pop something when the stack doesn't appear to have anything in it. I can't pop. So I'll say stack underflow, printf, stack underflow, and I will return right there. But now I have to give a value with a return. Normally, in such cases, we return -1, provided we only have valid values like positive values in the stack. Okay, so tentatively we'll put return -1. Okay. When the stack is empty, right? You agree with this piece of code? Else. Else means cur size is not equal to 0. There is something in the list or something in the stack. This list we are treating it as a stack, correct? So, how do I say that? Now, remember there is a head pointer which is now pointing to the head, which will automatically get updated by add nodes. So, can I not do something with the head and get value out? What should I say? So, the data which needs to get returned is what the data my head node has. And because I am getting rid of that guy, my head has to advance. So what I will do is, because there is a bit of pointer manipulation, I will create a temporary pointer. It's always a good thing to do that. So I will say struct node star temp, and I will assign it to head to begin with. Okay, just notionally I will put it equal to head just to start the game. Then I will say, okay, okay. Now I have to remember, give back the value. So I have to create a variable to hold the value which is sitting there. So int v value, some variable, int v equal to, can you help me with that? What will I say? Temps data. The value which has to, temp is now head, right? So whatever is that at the head, whatever value is sitting in the head node, I have to extract it and put it in v. So I am saying int v is equal to temps data. Temp is a pointer, so I use the arrow, and every node has this data in it, right? So int v is equal to temps data. I got temps data. Now I am yet not done. I have to do a couple of more things. Okay, can you help me? What is next I have to do? Should the head change? Should the head change? Because remember I am plucking out the first guy in the head. That is what is popping, no? So head should change. So what should I make the head as? It should move forward. Okay. So the new head should be this head's next. Remember, it's a linked list. So I am knocking this guy off. If I am knocking this guy off, my head, new head, should be one ahead. Should be heads next. The previous heads next is the new head. So I will write that line, head equals heads next. Okay. We got that going. We still need a couple of more lines maybe. What is that? Huh? Beautiful. So now, not head, temp. Head is moved forward. You don't free that guy. Free the previous guy, which is temp. Correct? You shouldn't free head, please. Head has already moved ahead. So what was the old head which is sitting in temp? That has to go. Free temp. Now, we need one more line, just one more line. Okay. Good. So I'm getting rid of one node, right, from the list. So size should increment or decrement? It's losing one node. So size should diminish, should come down. So I should say cur size is equal to cur size minus 1 or whatever. Cur size minus 1. We have to diminish the stack, the size, because I am accommodating somebody. Cur size minus 1. Yeah, one more line left. I have to give back, no? pop has to return a value. So what will I say? Return, what should I return? V. That is the data I have taken from the head of the list. So V. So if you notice, these are all very interesting steps. I have a head. Head is pointing to a list. Next, like that. Now I have to get this guy out. So look at the steps I am doing once again. Struct node start temp equal to head. So I am making temp point to head. Then I am saying whatever temp is pointing to is the head of the list. Let's take the data out of it. So temp's data goes into V. We did that. So I am having a V in which I have put the data. Then I know now the head has to move ahead because I am knocking off the head. Head is equal to heads next. Right? Next line. Yeah. Now, whatever temp is pointing to, which is the old head, head has moved ahead. Temp is still pointing to the first head, the old head. So I need to get rid of it. Head has already moved ahead, so this guy can go. Free temp, because I am getting rid of one value from the stack, it's obvious that the stack size should come down. Cur size is equal to cur size minus 1. Then return V, because the pop has to give back value. Now, if I have written this correctly, what is the proof of the pudding? My main should work like the way it should work, correct? Like a stack. So what we are going to do is we are going to compile this code and see whether we get appropriate results in main. Okay, we have some warning. Yeah, the same problem we had earlier. Add node should be above, no? Because add node is being used by push and pop. Okay, so we put add node before. We will change that with prototypes. This pushing up, pushing down is not a good habit, but you have to suffer a bit so that we'll replace it. Okay, now, okay, can we make it bigger? Okay, this is the output we are getting. First we are getting a stack overflow, then we are getting 50, then we are getting 40, and then we are getting 25. Is that what is expected? Okay, let's go to the code and assure ourselves that that is what we are supposed to get. Let's look at the main. So 10, 20, 30, 40, 50, 60. The first pop on line 151 gave us a stack overflow. Yes, because our size is 5. When I tried to insert 60 in it, I got an overflow. Agreed. Then line 152, when I did a pop now, okay, so I got a 50. 150 gave me a stack overflow, right? 150 gave me a stack overflow. So 60 didn't go into the stack at all. Then when I popped, I got 50. Then I got 40. Now the top of the stack is actually 30. But at that time I pushed 25. So now my stack is from bottom up 10, 20, 30, 25. Then I did a pop. I got 25. Now if I do a pop, 154. We'll do a pop. What should I get? What should I get? What is the value I should get? See, look at it. 10, 20, 30, 40, 50, 60. 60 couldn't get in because of the overflow. When I did the first two pops, 50 and 40 went away. They were popped, head moved ahead, they were released. So at that point, our linked list is looking like, what is there in the linked list? 30, 20, 10. Head is 30, then 20, then 10. Then I did a push. Because of the push, now how my list looks? 25, 30, 20, 10. Then I did two pops. So 25 popped, 30 popped. So now 25, 30. At this stage, what is my linked list? 20 and 10. We can check that. Okay. So come down. So if I say now, repeat 155. This will give me a 20. Again repeat. This will give me a 10. And again, okay. What will I get on line 158? Stack underflow and I'll get -1. Because that is how we have written our underflow situation. Okay, let's check that. Let's check whether we are getting that. So we'll run it. Yeah, as expected, we got an overflow with 60. Then we got 50, 40, 25. Then we got 30, 20, 10 in the LIFO order. And if we did a last pop, there was nothing there. So we got an underflow. And when there is nothing, it gives back -1. It gives a message and gives back -1. So that's how it worked. Okay. Now, ideally, you should be able to work this out. You should be able to understand. Now, we just have one exercise left, which is called Q. Very similar to this. Only thing is, instead of implementing a LIFO, we'll implement a FIFO. Okay. It will be very easy to build that. Yes. And that is what we'll do next.